Good day, students. Welcome to part one on our review on integration techniques. We're going to be going over a problem that involves integration by parts and substitution. Okay, so the instructions are for us to evaluate the following integral, evaluate the indefinite integral of x to the third over the square root of x squared plus 1 dx. Okay, now I'm going to be doing this integral using two methods. I'll do the long way using integration by parts and substitution, then I'll show you another elegant approach that can be used to evaluate this integral. Okay, so method one, we're going to use we're going to do integration by parts and substitution. Okay, all right, so what I'm going to do here is set this integral in such a way that I can do integration by parts. So if I express this integral in the following format, x squared times x divided by the square root of x squared plus 1 dx, what you notice is that it's easy for me to find an antiderivative of this expression right here. I'm using u substitution, and then I can differentiate this with ease. Had I used the reverse process, call this dv and call this u, then when I differentiate this, it looks very complicated and it makes our life much more difficult. All right. So in this case, I'm going to call my u. My u is going to be x squared, and my dv is going to be x divided by the square root of x squared plus 1 dx. All right. Now remember the formula for integration by parts. Let's rewrite it here. Is the integral of u dv equals uv minus the integral of v du. All right. So in this formula, we know that u is x squared. So all we just need to find is v and du. All right. So let's find du first. We'll accomplish that by differentiating u using differentials. If I differentiate u, I'm going to have 1 times du. Applying the power rule here, I'll have 2x dx as a derivative of x squared. All right, let's shift our attention to dv. In order to figure out what v is, I will have to find the antiderivative of this side of the equation. Okay, so v basically is the antiderivative of x divided by the square root of x squared plus 1 dx. Okay, now in order to evaluate this integral right here, we'll have to use u substitution or integration by substitution. Since I already have my u alphabet taken, how about we use w here? All right, so to evaluate this integral, if you notice, if I differentiate x squared, I'll have a multiple of x, namely 2x. So I'm going to call the innermost function of my composite function 1 over x squared plus 1. I'm going to call that w, so let w equals x squared plus 1. Now if I differentiate that, that tells me that dw is equal to 2x dx. Okay, notice we have x dx over here, so that means that I need to get x dx by itself. To accomplish that, I need to divide both sides by 2, and then I'll have dw over 2 is equal to x dx. Now we're ready to make our substitution. Okay, so we're still trying to figure out what v is. We have to evaluate this integral to figure out what v is. So we're going to have the integral of this piece, 1 over the square root of x squared plus 1, can be written as 1 over the square root of u, or we're calling it w this time. And then our x dx over here, our x dx will become dw over 2. Okay, so dw over 2. Now let's rewrite this in such a way that's easy for us to evaluate the integral. So in order to do that, we're going to use the properties of exponents, the reciprocal property of exponents, and the special case of the nth root. So we're going to have this integral of w to the negative 1/2. This 2 can be factored out, so we'll have a 1/2 in front here, dw. All right? And we can clearly see that this is easy to integrate. If we integrate this using the power rule, we're going to have 1/2 times, we just add 1 to the power and divide by, add 1 to the power. So negative 1/2 plus 1 is the same thing as adding 2 over 2, so you're going to have positive 1/2, and you divide by that value, which is also positive 1/2. All right, and then when you multiply the numerator by the reciprocal of the denominator, you find out that your antiderivative v is w to the 1/2. Okay, so we know what v is. V is w to the 1/2. So we have to do some work in order to get what the value is. But we note that we're working with x's, right? So we have to express v in terms of the same variable as du and x and dv. So we need to change this back. In order to do that, we're just simply going to replace w with its initial value, which is x squared plus 1. So w is equal to x squared plus 1 raised to the 1/2 power. Okay? Now we're ready to apply integration by parts formula. So we recall what the integration by parts formula is. Let me partition my workspace here so we don't get confused. Put it down here. So I'm going to write my integration by parts formula again so we can have everything organized. Okay? So integration by parts formula, we have the integral of u dv equals uv minus the integral of v du. All right? So we know that u is x squared. V that took us so long to find is x squared plus 1 raised to the 1/2. So that's uv minus the integral of v, which is same thing, x squared plus 1 raised to the 1/2 du, that's 2x dx. Okay? All right, let's take a look at this integral expression for a second. Do you think we can do this by integrating by parts or by use substitution? If you notice the inner function of this radical function right here, if you differentiate it, do we get a multiple of this other function? The answer is yes. So we do not need integration by parts. We can use the reverse of the chain rule or integration by substitution to evaluate this piece over here. Okay? All right, so to do that, all we're just simply going to do is we're going to call u the inner function of this composite function right here, which is x squared plus 1. And then du is going to be 2x dx. This is a perfect case because we do not have to divide by anything. This du right here is a perfect replacement for this 2x dx piece. All right? So now let's put it back into the integral. So it's going to become x squared times x squared plus 1 raised to the 1/2 minus the integral of u to the 1/2, replacing this x squared plus 1 with u, and then 2x dx is nicely replaced with du. Now we can apply the power rule to evaluate this integral right here. If we do that, we're going to have, it's going to become x squared times x squared plus 1 to the 1/2 minus, applying the power rule to this expression, we'll have u to the 3/2 over 3/2. Okay? And plus the c constant. Now we notice that our variable isn't originally what it was, so we need to replace what u is to express this whole function in terms of x. We know that u is x squared plus 1. All right, so let's apply that back. So our solution is going to be x squared times x squared plus 1 raised to the 1/2 minus, you multiply the numerator by the reciprocal of the denominator, we have 2/3. And then u becomes x squared plus 1 raised to the 3/2 plus c. All right, so there is your answer. You can leave it like this, but let's make it look pretty. Okay, let's beautify it a little bit with some algebraic steps. Okay, so you can stop here, but I'm going to take it a little bit further, make it look nice. You notice that we can make a factorization here. What if I write this expression like this? What if I wrote it like x squared times the square root of x squared plus 1 minus 2/3. Now, if you think about 3/2 is 1/2, right? So x squared raised to the first power is simply x squared plus 1 raised to the 1, but we don't have to put that. And then the 1/2 piece is square root of x squared plus 1 plus c. Now we can factor out the square root of x squared plus 1, right? Let's go ahead and do that. Factor out that radical piece. So we have the square root of x squared plus 1 times x squared minus, you can distribute this -2 to the numerator. We have minus 2x squared minus 2 over 3. Okay, plus c. And then we can find the LCD here. Just multiply this by 3 top and bottom. 3 over 3. And if we simplify, we're going to have the square root of x squared plus 1 times x squared minus 2x squared is just simply x squared minus 2 over 3 plus c. And there goes your final answer. Okay, so that's that. All right, you notice how long it took us? Well, let me show you another way of doing this same problem, much more elegant and fast. You don't need to use substitution and integration by parts. So method two, we're going to find the integral of the same expression, okay? All right, so we're integrating the same expression. So we're going to find, let's see here, the integral of x to the third divided by the square root of x squared plus 1 dx. Okay, now let's make some substitutions here. Now, how about we say, let's call u the square root of x squared plus 1. Okay, if we square both sides, we'll have u squared equals x squared plus 1. If we subtract 1 from both sides, we have u squared minus 1 equals x squared. Okay, so we basically have a replacement for x squared plus 1. Now, how about the x situation? How are we going to do that? Well, we'll just simply differentiate this, right? So if we differentiate this, we're going to have 2u du equals 2x dx. All right? So if we can express this in such a way that we have x dx isolated, then we should be able to evaluate the integral. You notice that there are two 2's present, and we want x, we could get x dx by itself. So how about we go ahead and divide both sides by 2 here. Divide by 2, divide by 2. And then we have u du equals x dx. Okay? All right, now let's go ahead and make the substitution. You'll be impressed to see how easy this is going to be. So we're going to have, let me write it in a way that makes it easy for you to understand. So this will be the integral of x squared over the square root of x squared plus 1 times x dx. Okay? All right, let's make our substitution. We know that x squared is u squared minus 1. So we replace the numerator with u squared minus 1 over the denominator x squared plus 1. The square root of x squared plus 1 is simply what? It's simply u, right? So let's call that u. And then x dx is what? X dx is u du. All right? Now let's take a look at this expression. What can be done here? You notice that the u's can cancel out, and we're going to have the integral of u squared minus 1 du. Okay? Now we can use a power rule here. It's pretty straightforward to evaluate. So this becomes u to the third over 3 minus u plus c. Okay? Now remember that the original problem was in terms of x's, right? So we now have to put our x's back into the equation. Wherever we see u, we're going to put the square root of x squared plus 1. Okay? So we're going to have the square root of x squared plus 1 to the third power over 3 minus the square root of x squared plus 1 plus c. Okay? Now let's do some cosmetics here to make this problem look pretty. So what we're going to do is rewrite this in the following format. I'm just going to simplify it a little bit. So this is going to become, you can write it as the square root of x squared plus 1 square times the square root of x squared plus 1 over 3 minus, we can find the LCD in this situation here, so we can combine the two fractions. So multiply, put this over 1, multiply by 3 top and bottom. 3 times the square root of x squared plus 1 over 3. Okay, so you notice this is to the third power, so I just basically split it up. I took the first 2, so I can cancel this out, and then I have root x squared plus 1. Okay, this basically applying the properties of exponents here. All right, so let's see. The square root of x squared plus 1 can be factored from both sides. So, but just a side note, this is good enough. This is an answer. You can leave it like this. I just want to make it look nice, okay? Just simplify a little bit further. So I factor out the square root of x squared plus 1 from both sides. So I'm going to have the square root of x squared plus 1. Now this square and this square root cancels out, so we're left with x squared plus 1, and then minus 3, and this entire business over 3, okay, plus c. And then our final answer is simply going to be the square root of x squared plus 1 times x squared minus 2 over 3, okay? And there goes your final answer, much faster than the other method, and less room for error, okay? So that's that. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel. I'll really appreciate it. And please post a comment to let me know what you think about this clip. More clips can be found on mathgotserved.com/calculus. Thanks again for watching, and have a wonderful day.